Okay, guys. For example number 3, we've got some data that we want to talk about here just before we get started. It says misleading data displays. The way a data display is drawn can lead people to make incorrect conclusions. All right. 3 examples of potentially misleading data displays are shown below, and you've got them on your notes. This first one is a broken vertical axis. Do you see that the distance between this is 160? Right? It jumps from 0 to 160. But what's the distance from here to here? Just 10. Even though the physical distance, right, when you look at it, they look exactly the same. But this distance, right? This distance right here stands for 160. This distance, which is the same length, stands for 10. And this one stands for 10. And this one stands for 10. Look, it makes this look 3 times or 4 times as big as this one, but is it? No, because it's at what? 188, and then this one's at 160. It's not 3 times as big. Do you see how it's misleading? Or it can be misleading. All right. Let's look at this one. Let's see. Large increments. The large increments on the vertical axis minimize the changes in the data. Okay? This is a pretty big change. When it goes from 1,000 all the way up to 1,600, right? 1,000 to 1,600. It doesn't look like that big of a change. But 1,600, that's a full third of, it went up by 600. That's over a 50% change. Yeah? Does that make sense? So when you don't give a lot of distance, when you don't give a lot of scale to it, it makes these jumps look smaller. Okay? This one made the jumps look bigger. This one makes the jumps look smaller. What do you think's the problem with this one? Yeah, Simon?
Well, they're different widths.
Yeah, exactly. February and March, they're really not that different. February is a little higher. It's at what? You think 18? Maybe 19? Whereas March is at 15 or 16? Yeah. But because February's fatter, right? Because the bar's fatter, that makes it just look that much more because it carries more area. Okay, so the width. And then April, it looks like I could fit 1, 2, 3. It looks like I could fit 5 or 6 Marches inside of April. When April's just 31 and March is about 15, it's about twice the size. Yeah. But it looks like it's about 6 times the size. Okay? Yeah, Simon.
Wait, so with the widths,
yeah,
why would they do that? Have you ever seen that?
Yeah. Politicians like to do it a lot.
Why?
They like to lead you to make certain conclusions.
Because they could be the same height, but they may be different widths.
For instance, I've seen stuff like this come from different governmental agencies, like how much garbage we pick up, and they make, the garbage can look bigger when it's really not that much bigger. Or, a politician may say, oh man, look at this. Let's say that this is 0% and this is 7%, but we're going to do a broken line graph and make this 6%. And this is where unemployment was when somebody, whoever, took office, and it went to here, and then it went to here, and then it went here, and then here, and then here, and then here, and then here. Okay, well, yeah, but that's not that big of a deal. That's between 6 and 7%. Yeah. Right? But it looks like a huge increase because they lopped off this part of the graph. Right? Okay, let's look at this first example. Example 3 says, the rightmost bar in the histogram above appears to be twice as long as any of the other bars. Now here's the histogram, right? Okay. Is the frequency of the 10 to 12 interval twice as great as the frequency of any other interval? Well, is it? Let's look at it. Here, let me get rid of all this stuff. Yes, sir. I'm getting close. Yeah. Okay. So this is what, 188? And the smallest one is 160. So is it possible that it's twice as much or 3 times as much any of the others? No. It wants us to regraph the data without a